Hello friends. Now let us take one example of CurveTracing. Here I have written one example. This equation is in Cartesian form, as you see that x and y are involved. Now a is any constant, and usually they mention what kind of constant is this. Here they have mentioned that a is a positive constant. Okay, so the value of a is positive. Okay. Now, before we start, let me just explain that. See, we are tracing this curve. That means we are analyzing the equation, okay, one by one. And finally, we will try to draw a rough picture of this curve, okay. So here in this part, I'll do the analysis, and here we will try to draw this curve. So this is x-axis and this is y-axis. So finally, from the analysis that we are making, we'll definitely try to draw a rough sketch of this curve. Okay, so finally we'll do this. Okay, so to proceed with, I'll go with the step-by-step analysis. So solution. Step 1. Okay. First of all, let me rewrite the equation. So I'll write the equation as, I say given equation is y equal to 8a cube divided by x square plus 4a square. Fine. Okay. Now, so this is the equation, right? Now you observe that here y is of odd degree and x is of even degree, right? That means if I replace x with minus x, there is no change in the equation, because minus x square is also x square. Okay, so this implies, so I say since x replaced by minus x, no change in the equation, okay, no change in equation. Therefore, what our rule says that of symmetry, therefore the curve is symmetric about y-axis. Okay, that means now you can expect that the curve exists like this. Okay, so even if you find out the part in this one, this part of the plane, you can just replicate that and you get the other part of the curve. Okay, right, because it's now symmetric. Okay, so this is our first step. Second step, okay, we will find out whether the curves passing through origin or not. Okay, so what we will do is we will substitute x equal to 0 and y equal to 0 to find whether the curve passes through origin. Okay, whether the curve passes through origin. See, suppose, so put x equal to 0, y equal to 0. Okay, and check whether the two sides are same or not. Okay, now if I put here y equal to 0, I'll get here 0 equal to 8a cube divided by 0 plus 4a square, and that is equal to 2a. So certainly 0 is not equal to 2a, right? And that implies what? That implies the curve is not passing through origin. The curve is not passing through. See, these are all results that we need to analyze. First result we obtained, it is symmetric about y-axis. Second result now we have obtained, it is not passing through origin. Okay, understood? Now let us go for the next one. So step 3. Fine. Now see that the curve is symmetric about y-axis like this. Okay, it is not passing through origin. Fine. Then since it is symmetric about y-axis, it should intersect y-axis somewhere, obviously. So we will find out that point of intersection. So to find point of intersection with y-axis, point of intersection with y-axis, and it is very simple to get. What is the equation of y-axis? It is x equal to 0. So substitute that equation in this and solve. So put x equal to 0. Okay. So if I put x equal to 0 over here, what you will get? Okay, so this becomes 0, 0, right? So this is equal to 2a. Y is 2a. So put x equal to 0, we get y equal to 2a. So what is the point of intersection? Therefore, 0, 2a is a point of intersection. Is a point of intersection. Got it? Okay. So suppose, let me draw it here. This is 0, 2a. Fine. Now see that at 0, 2a, at this point, okay, curve exists. It is something like this, but the curve exists at 0, 2a. Let me draw, now obtain the nature of tangent at this point. So my next step will be step 4. See how we are developing our analysis. Nature of tangent at 0, 2a. And how you can obtain this? Just differentiate the given equation with respect to x. Get dy by dx and substitute this point. So you'll get the nature of tangent at this. So slope. So we are actually interested in finding the slope of the tangent at this point. So we'll say since y is equal to 8a cube divided by x square plus 4a square. Okay, so differentiate this equation with respect to x. What you'll get is dy by dx equal to, now 8a cube is a constant, okay, and this is 1 upon x square, right? So it is minus 1 upon bracket square into 2x. Fine. Now if you put here this point 0, 2a, okay, so x is 0 and y is 2a. Now x is 0, so this will be 0. See, x is 0, so this entire thing will be 0. So the slope is 0, and you know that when the slope is 0, the tangent has to be parallel to x-axis, right? So at this point, the tangent has to be parallel to x-axis like this. This is the tangent. Okay, and whenever the tangent is parallel to x-axis, either the curve is having this as a maximum point or this as a minimum point. So your curve can be like this or it can be like this. Any one of these cases. Okay, fine. So we'll try to find out which kind of curve that we have here. Okay, fine, up to this. Okay, so let's proceed. Now we'll find out the asymptote. The asymptote. And asymptote will directly give us the picture of this curve now. Okay. See, so now the curve is symmetric about y-axis, right? So the asymptote, whatever it exists, that must be parallel to x-axis, right? And how will calculate the asymptote parallel to x-axis? That is, so I'll write here, since curve is symmetric about x-axis, sorry, y-axis, the asymptote is parallel to x-axis. Okay, the asymptote is parallel to x-axis. So to find out this asymptote, what we will do is you equate the highest degree term, the coefficient of highest degree term with 0 to 0. The coefficient of highest degree term in x to 0. Okay, fine. So let us go back to the equation. The equation is y equal to 8a cube by x square plus 4a square. Is it correct? Yeah. So to get the see, this is the highest degree term. To get its coefficient, now let me take it to this side. So y times x square plus 4a square is equal to 8. Okay, if I simplify this, I'll get x square y plus 4a square y equal to 8. Okay, so the coefficient of highest degree term of x, so highest degree term is this and the coefficient is this, it is equal to 0. So y equal to 0 is the asymptote. Is the asymptote. What it means? This is the asymptote. That means this is the equation of x-axis. So x-axis itself is asymptote. That means after this there will be no part of the curve exist. Okay, so the curve must be in the above part of the x-axis. Okay, above part of the x-axis, it is symmetric. Okay, so we have determined the asymptote. Now see the region of absence. Now one region of absence we have already obtained by looking at the asymptote. There will be no part here now, definitely. Okay, so the region of absence. Now only thing we need to determine is whether the curve exists above this line or below this line. Okay, so consider this equation. Region of absence. Okay, fine. So now see that y is equal to 8a cube divided by x square plus 4a square. Right? Okay. So y square will be 64 a raised to 6 divided by x square plus 4a square bracket square. This is y square. Okay. Now see that if I put x is equal to x is equal to x square is equal to yes. So what we can do is, instead of doing like this, here x square is ready. So let us shift that to this side. X square plus 4a square is equal to 8a cube by y. So x square will be 8a cube by y minus 4a square. Right? Now to make this quantity to be negative, this quantity I need to keep smaller than 4a square. Okay, and when this quantity will be exactly 4a square, this quantity, when y is equal to 2a, when y is equal to 2a, this quantity will be 4a square and then x square will be 0. If I take y to be greater than 2a, then denominator is more than the numerator and Therefore this quantity is less than 4a square. Okay, then 8a cube by y is less than 4a square, right? Okay, you can just check this. Y greater than 2a, you can keep anything. So let us keep y as say 4a. Then this will be what? 4a. So it is 2a square. So it is less than 4a square, right? So this entire quantity will be negative. Then x square is less than 0. That means as you go above this line, as y is greater than 2a, your x square is less than 0. So values of x are imaginary, and therefore the curve exists below this line, right? And therefore this is the only picture that we can draw for this curve. Okay, this is the asymptote. After this there will be no part of the curve. It is not passing through origin. This has to be the maximum point because of this tangent. Okay, so curve is symmetric. So this is the picture of the curve. So this is the rough picture of the curve, and you can certainly check this on any graphics package that this curve looks like this only. Okay, I hope you have understood. Please go through this once again and try some more examples.